So what we're going to talk about today is the strategy to factoring a polynomial. We've learned all the different methods of factoring, but today what we're going to do is learn how to figure out which method applies when we're not told which method applies. All right, so this is our strategy or the process that we're going to go through to factor polynomials. If you follow this process, it will make it easier to figure out what method to use so that you get the correct factors. Because we need to factor in order to do other things in algebra, and so it's important that we factor correctly. So first of all, in how to factor a polynomial, the very first thing that we want to do is factor out the greatest common factor if there is one. Anytime you're asked to factor a polynomial, the first thing you want to do is look at it and figure out, can I factor out a greatest common factor? The answer may be yes, the answer may be no. But the issue is if the answer is yes, that is the first thing that you want to do. You want to factor out the greatest common factor. After you do that, you may be left with a polynomial, and that may factor further. The fact that you have now factored out the greatest common factor will make it easier to do the next step. So in order to do the next step, after we've factored out the greatest common factor, if there is one, is we are going to ask ourselves, how many terms are there? In this class, there's either going to be 2 terms, 3 terms, or 4 terms. So what I have is what you do if you have 2 terms, if you have 3 terms, and if you have 4 terms. That's going to determine what method you're going to use next. If you have 2 terms, right here, 2 terms, we will check for the difference of 2 squares, all right? And that's a method that we learned yesterday. And let's scan to the bottom of the screen here so that we can see the formulas, all right? So the difference of 2 squares is a polynomial that looks like this. Something squared minus something squared. And it would factor like this. All right? That may not apply. So check for the sum or difference of 2 cubes. That means something cubed minus something cubed or something cubed plus something cubed. All right? Those are the formulas that you're going to look to use if you have 2 terms. It may be that your polynomial with 2 terms does not factor further. That's okay. But you want to look for these patterns in case one of those 3 patterns does apply. All right? Now, if you have 3 terms, we talked about 3 different methods. First of all, when you have a polynomial with 3 terms, you are thinking about something that's in the form ax squared plus bx plus c. In other words, a quadratic. All right? If that a is a 1, so in other words, it just starts with x squared, this is easy. Use guess and check, okay? In other words, what multiplies to the c and adds to the b, okay? If that's not what you have other options. First of all, check to see that it is or isn't a perfect square trinomial. Remember what those are? They follow the form something squared, and they end with something squared, and then the middle is 2 times this something times that something. Check for this pattern. Before you go to the box method, check for this pattern, because if it follows this pattern, this formula is going to be a lot easier than trying to use the box method. If it doesn't follow the pattern for a perfect square trinomial, and it doesn't start with x squared, so in other words, it starts with a number in front of x squared, then you're either going to have to use guess and check or the box method, whichever of those methods you've decided that you are comfortable with. Some of them may be easier to guess and check, some of them may be easier to use the box method. Remember, if you're starting with something like 5x squared, you know it's going to be 5x and x, so that may be easy to do guess and check on. But if you're starting with something like 12x squared, that could be any number of things. So then you may want to use the box method. If you have 4 terms, you're going to use factoring by grouping. And if you recall, we did that quite some time ago. So you might have to review your notes and remember factoring by grouping. But if you have 4 terms, that is the method that you are going to use. Now, down here in the box, you're going to see a little hint. It says after you go through this process, check each of your factors and see if they will factor further. So now that you have done this and you have factored, you have to check your factors. If you still have a factor that has an x squared or an x to the third, this may go further. You need to check that. One of the biggest mistakes is to get your factors and not realize that what you have left is a difference of 2 squares. Okay? And a lot of times that will happen because one of your factors might be x squared minus 1, which is x plus 1, x minus 1. All right? So you want to make sure that even after you've gone through this, check your factors. If you still have x to a power in one of your factors, this may factor further. All right, so the next thing that we're going to do, now that we've learned a strategy for factoring polynomials when we're not told which method to use, is we're going to go through some examples. So first of all, I have example A. And remember, you always want to check for a greatest common factor. Sometimes if you have one and you don't get rid of it first, it's going to make factoring it very difficult. So you always want to look for that first. So the first thing I'm going to do is notice that I do have a greatest common factor. That is x. And I'm going to take that x out to the front. And what's left in parentheses is x squared plus 12x plus 20. All right? Now I have 3 terms, so I'm going to follow the strategy for 3 terms. This quadratic starts with x squared. It's one of the easy ones. All I have to do is figure out what multiplies to 20 and adds to 12, and that is 10 and 2. So this is x plus 10, x plus 2. Now I need to check to see if I can factor further. I don't have any power of x here, and I don't have any power of x here other than 1. So I'm not going to be able to factor further, and let's go on to the next problem. So the next one is 4x to the 4th minus 4. And again, first thing I want to do, look for a greatest common factor, and I do have a greatest common factor of 4. So I'm going to take that out, and it's going to leave me x to the 4th minus 1. Now, I have 2 terms here. So I'm going to look for this difference of squares or the sum and difference of cubes. Now this is the difference of squares. X squared times itself and 1 times itself. And remember how the pattern factors a plus b, a minus b? So here, don't forget, bring down that greatest common factor. Don't leave it up at the top somewhere. It needs to come with your whole polynomial. So we said x squared plus 1, x squared minus 1. All right? Now, we have to ask ourselves, can we factor further? So the next thing we want to do is look at these binomials and see if they factor further. I have 2 terms. So remember the 3 patterns I'm looking for? Now this one is the sum of 2 squares. And remember, in our notes, we talked about the fact that the sum of 2 squares does not factor. All right? So this won't go further. This is the difference of 2 squares, x and 1. So this will go further. So now we're going to have 4. Make sure you bring that down. Bring down the x squared plus 1. And the x squared minus 1 factors to x plus 1, x minus 1. Now we're going to check and see if this will go further. We said this doesn't. We have a power of 1 here and a power of 1 here, so we're done. Let's go to D. We'll skip C for a moment, and we're going to go to D. All right, with D, first thing I'm going to do, factor out my greatest common factor, if there is one. And I have a greatest common factor, and that would be 2. So I'm going to factor out a 2. And I have left x squared minus 2x minus 35. The next thing I'm going to do is use my strategies to factor this. I have a trinomial, 3 terms, and the number in front of x squared is just 1. So this is going to be an easy one, a guess and check. I'm looking for what multiplies to negative 35 and adds to negative 2. That is negative 7 and positive 5. So I have 2 times x minus 7 times x plus 5. Now I have a power of 1 here and a power of 1 here, so this isn't going to factor any further. I am done. Let's take a look at E. We start with the x to the 4th, then we have an x squared and a number. I don't have a greatest common factor, but I always want to check for that first. So I have 3 terms. This is actually one of the easy quadratic trinomials, because there's no number in front of the x to the 4th. So what I'm looking for is what multiplies to 9 and adds to negative 10. And remember, my 2 binomials will start with x squared and x squared. So this is negative 9 and negative 1. So here's what I have. X squared minus 9, x squared minus 1. Now what I've got to do is see if this will factor further. I do have a power of 2 here, so it might. I have 2 terms. So the patterns I'm looking for are difference of 2 squares or sum and difference of cubes. This happens to be the difference of 2 squares, x and 3. So this is x plus 3, x minus 3. Now, go to x squared minus 1, and I'm going to look for those same patterns again because I have 2 terms. And again, guess what? This is difference of 2 squares, the square of x and the square of 1. So x plus 1, x minus 1. Now, all 4 of our factors have the power of 1, so they're not going to factor further, and we are done. All right, let's take a look at F. F has 4 terms in it. All right? Remember our strategy for 4 terms? Well, first, let's see. Do we have a greatest common factor? We don't. All right. So we're going to go to the strategy for 4 terms, which is factoring by grouping. So now you've got to go back a little bit in time and remember factoring by grouping. And we do have a minus sign here. So let's remember what we need to do with that. So let's make our groups. We're going to start with 3x to the 3rd plus x squared. Put a plus, put that negative in front of the 12x in the parentheses. All right, from our first group, let's factor out the greatest common factor, which is x squared. That leaves us with 3x plus 1. Now, we want to factor something out of here that will hopefully leave us with a 3x plus 1. So our greatest common factor is 4, but in order that these 2 will match, we're going to factor out a negative 4. And that will leave us with a positive 3x and a positive 1. Now, the only reason we can continue is because these 2 binomials are the same. So we're going to factor out the binomial, 3x plus 1, and that leaves us with x squared minus 4. Now, we have to ask ourselves, can this go further? So let's take a look. Here we have a power of 1, so this isn't going to go further, but this is the power of 2. So let's try and see if it will go further. This has 2 terms, so I'm looking for difference of squares or sum and difference of cubes. This is the difference of squares, the square of x and the square of 2. So this is going to be x plus 2, x minus 2. So bring down your 3x plus 1. and this becomes x plus 2, x minus 2. Now, all of our factors have a power of x that is 1, so they're not going to factor further. At this time, let's go back up to c. We skipped over c. c, if I look, does not have a greatest common factor. I have two terms. So I'm looking for sum and difference of cubes, or I'm going to look for the difference of squares. Notice, I can't use sum of squares because remember we said that doesn't factor. So here's what I've got to use. Since it's a sum, I've got to use cubes. All right, so this is the sum of cubes. So something to the third power and something to the third power. All right, so this is x squared to the third power, and this is going to be 4 to the third power. So remember how we did this the other day. The x squared works like our a, the 4 works like our b in our formulas. All right? So let's go back to our formula for the sum of cubes. And that formula looks like this. A plus b, a squared minus ab plus b squared. All right, so we're going to apply this formula to this particular polynomial. So the first thing I'm going to start with is a plus b, so x squared plus 4. Next, I'm going to start with a squared. So that's x squared squared, which is x to the 4th, minus a times b, which is x squared times 4, or 4x squared, plus b squared, which is 4 squared, or plus 16. Now, I will tell you, when you use the sum and difference of cubes formula, the binomial part may or may not factor. This one does not factor further because it's actually the sum of two squares, which doesn't factor. This, don't worry about factoring. Sometimes it does, sometimes it doesn't. But we have not learned any method in here to help us factor this further if it does. So when you get the trinomial using the sum and difference of cubes, know that that trinomial is done. You do not need to factor it further. It's at a much higher level that you would learn how to factor something like that. Now let's go down to the bottom. We have G. G is a fun problem. And this works a little bit differently than you might think. So first of all, we don't have a greatest common factor, and we have 4 terms. So that means factoring by grouping. But I'm going to point something out to you, that this one works a little bit different. And if you put together the first 2 and the second 2, and you took an x out of the first 2, you would get x plus 6. And there's no greatest common factor here. So then your 2 binomials would not be the same and you could not proceed. So remember what our strategy was if that happened? Our strategy was to switch the middle 2 numbers to see if this would work. Then we have the x squared with the 9 and the 6x with the minus 4y squared. But if you look at that in your mind, there's no greatest common factor to take out between x squared and the 9. And over here with the 6x and the 4y squared, you can take out a 2, but that's going to leave you with 3x minus 2y squared, and still they're not the same. And that is because this is going to group a different way. I'm not going to give you a ton of these to do, so don't look for it on every single problem. But if you're using grouping and it doesn't work the way it's written, and you switch the middle 2 and it still doesn't work, this may be what the situation is. We are going to group this differently. We're going to group the first 3. All right? Now, I'm going to factor this. And I have a trinomial. And this is actually a perfect square trinomial. This is something squared. This is something squared, an x and a 3. And the middle is 2 times x times 3. All right? So I take my x and my 3, and it factors to x plus 3 quantity squared. Then I have minus 4y squared. Now this is really cool, because actually what I have here is a polynomial with 2 terms. This is one term, this is another term, and it happens to be the difference of 2 squares. The square of x plus 3 so that's our a, and the square of 2y. So remember our formula for the difference of 2 squares. This is a plus b, a minus b. This here is your a, this here is your b. So a plus b would be x plus 3 plus 2y. A minus b would be x plus 3 minus 2y. So now you have 2 trinomials. And since these are not quadratic, there is nothing that we can do to factor them further.